Hi guys, we're going to be working on factoring quadratics for a time now. So I wanted to give you a method that works to basically undo the math in terms of what got distributed over a binomial, what binomial was distributed with which binomial in order to give us this product. So where we're going to start is we're going to first of all recognize that we have three terms in this quadratic. The A term is always the term with the power of 2. The B term is always the term with the power of 1 or the degree of 1, and the C term is always the constant. What we want to do is replace this B term with two other terms that when added together equal the B term, so that they are like terms that add up to equal this B term. What we're going to do is have to select from numbers that are specific to this quadratic, and the only set of numbers we can choose from are those that are factor pairs of the product of A times C. So this is what I mean by the product of A times C. I'm going to multiply A and C. So 18x squared times negative 5 would give us a negative 90x squared. Now I'm going to look for factor pairs that equal this, but add up to negative 27x. Well, I'm going to start with the two numbers that I just multiplied with. So 18x and negative 5x. I'm splitting the x squared into two separate x terms. I'm going to check to see if the sum of these two numbers equals negative 27x, and in this case that doesn't work. So I'm going to continue working on factor pairs of negative 90x squared. The way I'd like to proceed is to actually redistribute a factor from 18 into negative 5. So I'm going to take 2. I'm going to divide 18 by 2, which would leave me with 9x, and then the 2 would have to get multiplied on this side, giving me negative 10x, and check and see if that adds up to equal the negative 27, and it doesn't. So I'm going to try again. I'm going to divide out a 3 over here, which would leave me with 6x. The 3 times the negative 5 would give me a negative 15x. That does not give me a negative 27 either. So let's try something a little bigger. How about 9? I'm going to divide this guy by 9, which leaves me with 2x. 9 times negative 5 gives me a negative 45x. Still not there. All right, we're going to try 6. Keep going. So if I divide this by 6, I will have 3x. 6 times negative 5 gives me a negative 30x, and voila, I think I finally got the correct pair. Now, in every single one of these factor pairs, remember, it's important to remember that the factor pairs have to actually multiply to equal negative 90x squared. And every single set of pairs here do. All right, now I'm going to replace this term with these two terms here, 3x and negative 30x. All right, and together when I combine these terms, I do get negative 27x. At this point, what I want to do is group the first two terms into a binomial and group the second two terms into a binomial. And by doing that, that allows me to look for a GCF that I'm going to divide out of each of these. All right, so the GCF for these two terms looks to me like it's going to be 3x. I'm going to write that down here, and I'm going to actually divide each of these terms by 3x. That leaves me with 6x plus 1. Over here, I can divide a negative 5 from both of these, and I'm taking the sign of this first term. It happens to be a negative, so I'm going to divide negative 5 from each of these terms. That's the GCF. So negative 5 is what we're dividing. So that would leave me with 6x and plus 1. Notice that I have a binomial in common here. That is actually one of my factors. This 6x plus 1 is actually one of the factors. Now, what got distributed over 6x plus 1 to get our product of 18x squared minus 27x minus 5? Well, 3x minus 5 is my other factor, the other binomial that was multiplied with or distributed with 6x plus 1. If I want to check to see whether or not this is truly the set of factors, then I would just remultiply these two binomials and double check that I get the same answer.